our discussion is about WURTZ reaction. WURTZ reaction is one of the important reaction which comes under organic chemistry in the synthesis of alkanes. In this reaction, there are many doubts for the students like why sodium is used, why dry ether is used, and what about the mechanism of the reaction. The reaction looks easy, but everyone has a doubt about the mechanism. So all these points we'll cover in this video. So let's start the discussion. So students, WURTZ reaction is about when alkyl halides, when they treated with highly reactive sodium, it produces alkanes and a sodium salt. So in this reaction, you can see the general reaction. Here R indicates an alkyl path, X is a halogen, sodium, it produces alkanes and sodium salt. So first of all, let us discuss about the mechanism of this reaction. So students, let us talk about the sodium. Sodium is a highly reactive metal. And what is the valency of sodium, students? Valency of sodium is 1. Its valence shell configuration is 3s1. So readily when the sodium comes in contact with this, so sodium loses 1 electron. Sodium loses 1 electron. If it lost 1 electron, sodium becomes Na plus ion and plus electron. This is the first step. So when sodium loses 1 electron, becomes Na plus and this plus electron. The electron which is lost in the first step, it reacts with this bond, the bond between R and X. R means alkyl, X means halogen. This bond is highly polar covalent bond. Why? Because halogens are highly electronegative in nature, right? And they readily want to gain the electron, which influences this bond. This halogen gains this electron and it becomes X minus. So what's the remaining part in this reaction? This bond breaks with homolytic fission. That means every element gets its electron back. And here X is gaining the electron of sodium. It becomes X minus. So what's the remaining part which is left in this reaction, students? R dot. R dot means R free radical. How many are there? You can see there are 2 moles of alkyl halides. When they dissociate, we'll get 2 moles of alkyl radicals and 2 moles of halides. Yes or no? Now, here also in the above reaction, we started this reaction with 2 moles of Na. So we'll get 2 moles of Na plus ion and 2 moles of electrons. These 2 moles of electrons influences 2 moles of alkyl halides. So now, these free radicals, which are alkyl free radicals, which are highly reactive, they combine with each other and they form the respective alkane. And what are the remaining which are left in this reaction, students? We have sodium ions plus halides. They combine in 1:1 ratio and they form 2 moles of sodium salt. So this is the mechanism of the reaction. First of all, what is the first step? When sodium loses 1 electron, it becomes into sodium ion, and this electron influences the bond between alkyl halide. So this electron was gained by the halogen, which becomes halide ion, and alkyl becomes alkyl free radical. So these alkyl free radicals, you can see there are 2 moles of them are there. So these 2 moles of alkyl halides combine and they produces alkane. And this sodium ion combines with halide ion, produces sodium halide. This is the mechanism of the reaction. But students, in this reaction, there are few key points are there which we need to discuss, like sodium. Why only sodium is used? Why not any other metals are used? So students, listen one thing. If any metal is mentioned in the reaction, it means that metal is suitable for that reaction. So why not lithium? Why not potassium? Right? Correct. So students, listen. Different metals show different kind of reactivity under different conditions. Here sodium is best suitable to react with alkyl halide, and one more reason is that so the salt which is produced from the reactant also matters. Also matters for the selection of the reactant. So that's why sodium is the best suitable for this reaction to react with alkyl halide. That's the first point. Next. So why not magnesium? Means magnesium valency is 2. We need one valency which is sodium, and we need highly reactive. So sodium is highly reactive metal. So next, the main point which is dry ether. So what is the role of dry ether in the WURTZ reaction? dry ether is used as a solvent. It acts like a medium in this reaction. So why do we need medium for the reaction? Yes, a reaction requires a medium. So first of all, practically students, when a reaction is taking place, like how does it takes place? How a reaction takes place? Like practically, think practically. You know how the reaction takes place? The reaction takes place when the reactant molecules collide with each other. When they collide with each other, the bonds will break and the new bond formation takes place. Exchange of electrons takes place. So that's the reason why we need to add some medium. Any medium should be taken. So why only dry ether? Like why not H2O? H2O is a universal solvent, right? So what's the use of dry ether? So students listen, instead of dry ether, if you can take H2O, sodium is highly reactive with H2O. Sodium can produce sodium oxides and sodium hydroxides, which we don't want. We don't want all that reaction. We want an unreactive medium, which is an organic solvent, which is dry ether. So that is the role of dry ether in the WURTZ reaction. It acts like a medium, and that medium should be unreactive medium. If water is taken, what happens? Water directly react with sodium. We cannot get the alkanes. So students, let us check few reactions which comes under this WURTZ reaction. Look at the first reaction. Methyl iodide reacts with sodium. So you answer the question. So what happens when methyl iodide reacts with sodium? You already know the mechanism. Sodium directly reacts with iodine, and what does it form, students? Sodium iodide. And what do we get? What we end up in this reaction? Two methyl free radicals, they combine and they produces ethane, right? And this reaction is simple, yes or no? You can directly check for the combination of sodium with halogen. And the remaining part, the alkyls, here it is a methyl iodide. So methyl free radical combines with another methyl free radical and it forms ethane. Is it clear, the first reaction? Now look at the second reaction. So students, what is the difference between the first reaction and the second reaction? First reaction is conducted by taking same methyl iodides. So alkyl halides. Here different alkyl halides are taken. One is ethyl iodide, second one is methyl iodide in the presence of sodium and dry ether. So can you expect the product in this reaction, students? So what is common? That is sodium iodide. So what is the other product in this reaction? Simple. So what does it form? Ethyl free radical, and here what it forms? Methyl free radical. So ethyl free radical which combines with methyl free radical and they form a bond. Now what is the compound, students? C2H5 and CH3. They produces propane. Is it clear, students? 2 carbons, 1 carbon. So total 3 carbons and 5 plus 3, 8. So students, answer in this reaction, is this only product possible or any other byproducts are there? Once imagine, you already know the mechanism. Here what we end up with, students? Here we end up with ethyl free radical. Here we end up with methyl free radical. They combine and they produces propane. Students, here many students will confuse. Listen carefully. In this reaction, students, like how many ethyl free radicals are there? In this reaction, how many ethyl free radicals are there? So you're thinking about 1, right? But the answer is no, not 1. So here, students, this molecule, it doesn't indicate a single molecule. This molecule indicates 1 mole. 1 mole means 6.023 into 10 to the power of 23 molecules are there. That means, do we have only 1 ethyl radical? No. 6.023 into 10 to the power of 23 ethyl radicals and the same number of methyl radicals are there. So in these radicals, you already know, I already have said about the chemical reactions. Chemical reactions is all about the collisions. So every time, can we expect only the collisions between ethyl and methyl free radical? No. Sometimes we can expect collisions between ethyl free radical can collide with another ethyl free radical. Don't confuse. Many students will confuse here. Sir, where the other ethyl radical is coming? This indicates not a molecule. This indicates 1 mole. Does the reaction take place with a single molecule? Practically think. No, right, students? Many molecules are there of the same type. So this ethyl radical can combine with another ethyl radical, and what does it form? C2H5 and C2H5. What does it produce, students? It produces butane, which is C4 H10 is also possible in this reaction. And when this methyl free radical, when it can combine with another methyl free radical, what does it form? CH3 and CH3. C2H6. These compounds can also produce in this reaction. So what happens if other alkanes are also produced in this reaction? What is the problem? The problem is, students, can we get a pure product? The answer is no. Why? Because we are having another alkanes also. Now, why can't we separate? Yes, we can separate, but their boiling points are very, very close. So we can't separate so accurately. So ultimately we will end up with the impurity only. So this WURTZ reaction is not suitable for the preparation of odd number of carbon atoms. Is it clear, students? Got the clarity? Why? Why not? Why? Because we can expect different products, different alkanes. If different alkanes are there, they have very close boiling points. We cannot separate them so accurately. If we can't separate them, can we use for any other purpose for a single? No. Why? Because it is still impurity only. Next, one more point is, and the last point, we cannot synthesize the first alkane. What is the first member of alkane? Methane. Yes or no? How methane can be produced? What is the formula of methane? The formula of methane is CH4. The WURTZ reaction mechanism is all about alkyl free radical combines with another alkyl. That means minimum how many carbons should be there? 2 carbons. So for methane there is only 1 carbon. So methane can also be produced. Cannot be produced in this reaction, WURTZ reaction. So key points: sodium, highly reactive metal, sodium is used. Dry ether is used as a medium. Why? Because unreactive medium, unreactive solvent. Next, this reaction is not used for the preparation of carbons with odd numbers. And last point is, methane can also be synthesized in this reaction. So these are all the points about WURTZ reaction, students. I hope you got the clarity.